course, probability, sequences, series, and then we're gonna start studying calculus. So there'll be 4 tests. So tonight's homework is probability 3, and we just keep plugging along. We have a quiz on probability 3 and 4. What is this? This means no homework then. Just study for the quiz. What is that? It's weak, but we're gonna do it. Assembly 1, why are we, you guys know why we're having an assembly schedule next Monday?
Easter maybe?
Huh?
Easter?
Yeah, but how come we couldn't have like an extended assembly, or I don't know. Whatever. And then on the fair day, no homework either. What's going on? Well, that's fine with me. We kept up a good pace, so we don't really have to worry. So the test of probability is not going to be till the 13th then. All right. So first thing, let's go over the quiz. So this is like your review because you guys didn't have homework. You guys probably even forgot that you even took this quiz. You probably can't even remember any of the problems. But that's why it's good to have a quiz on the last day, because then we can review it. So this is what we did on probability 1 and 2. Number 1. The spinner above is spun twice. What is the probability that the sum of the 2 spins is equal to a prime number? So this is just like rolling 2 dice, except you're spinning this thing twice. So the easiest way to do this problem is write out the sample space. Write out all the possibilities. You can get 1 and a 1, 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 2 and a 1, 2 and a 2, 2 and a 3. And just write them all out. It's not that many, you know. Because some of you are trying to, if I remember, which is a long time ago, some of you are trying to do it without writing it out, and if you can do it, fine. But a lot of people weren't. Okay, so how many elements are there in the sample space? 5 by 5, 25. So the answer is going to be something out of 25. Now, I forgot what the problem was. Find the probability that the sum of the 2 spins is equal to a prime number. 1 plus 1 is 2. Is 2 a prime number? Yes. Is 3 a prime number? Yes. What about 4? No. What about 5? Yeah. 6 is not a prime number. 7 is a prime number. 8 is not a prime number. 9, no. 10, no. That's it then. So just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 25 then. So if you can write out the sample space, it's easy to do probability, but most of the time, there's so many elements in the sample space, it's not feasible to write it all out. So then you gotta rely on combinatorics. Number 2, 3 standard dice are rolled. What is the probability that the sum of the numbers showing is 7? So when you roll 3 dice, how many possibilities are there gonna be? Well, there's 6 choices on the first, 6 on the second, 6 on the third, 6 times 6 times 6? 216. Now you don't want to write all 216 out, but you know that's the denominator, right? Now you just have to count the numerator then. So we want the sum of the numbers to add up to 7. So how can the numbers add up to 7? You can get a 1, a 1, and a 5. But how many different orders can you put that in? Because remember, there's a first roll, a second roll, and a third roll, right? There's 3 different orders. It's just like how many 3-letter words can you make? What's another way that you could get a 7? A 1. Do it systematically. 1, 2, and 4. See, that's how I do all the ones with 1. How many different orders can you put that in? 6, right? Because how many 3-letter words can you make? What about 1, 3, 3? Yep, that adds up to 7. How many different orders? 3, right? How many 3-letter words can you make? 3 factorial over 2 factorial. Is there any other combination that gives you 7? What? 2, 2, 3. How many different orders? 3. Is that it? Did I catch them all? Yep, so add them up. Right, so if one person said it. And then of course, please reduce your answers. I remember some of you are not even reducing the fraction. All right, number 3. A committee of 4 is to be randomly selected from Ann, B, Char, Dot, Ellen, Fiona, and Google. So that's 7 people. Find the probability that Dot is selected and Char is not. Now, if you were to write out the sample space, what is 7 choose 4? That's the same thing as 7 choose 3. That would be 35. You would have to write out 35 possibilities, and this I gave you plenty of time. You could do that. But I think it's easier just to use combinatorics. How many ways can you select 4 people for a committee? 7 choose 4. That's the denominator. And the numerator, what does it say here? Dot is selected and Char is not. So, Dot is selected and Char is not. If you take them away, there's only 5 people left, right? And how many people do you need to pick? Huh? Because what does it say here? Dot is selected. That means Dot is already on the committee and Char is not. She's off the committee. So if you're going to make a committee of 4, how many more people do you need to select? 3. So it's 5 choose 3. See, so you write the formula down, you're going to get 3 out of 4 points already. So all you got to do now is simplify that. And I think we did. If you did it this way, it comes out to 2 seconds. Number 4, a 4-digit number is randomly selected. What is the probability that it contains at least 1 6? What do you do when you hear the phrase at least 1? You do the complement. What's the complement of at least 1 6? Because otherwise it just takes too long, especially a 4-digit number. No 6s. So what you want to do is compute the probability of getting no 6s and then subtract it from 1, right? So what's the probability of getting no 6s? Well, how many 4-digit numbers can you make? 1, 2, 3, 4. How many choices do I have for the first digit? Because when you make a number, it's a permutation, right? 9, anything but the 0. Now you can use the 0. 10, 10, 10, 9,000. That's how many 4-digit numbers there are, right? But how many of them have no 6s? Well, how many choices do you have for the first digit? Anything except the 0 or the 6. Anything except the 6. Anything except the 6. Anything except the 6. And then just subtract that from 1. And that's your formula. And then you just gotta compute that. I think some of us didn't reduce, but come on, look. Cancel. 9s cancel. 8 over 10 is the same thing as 4/5, and then you can't really simplify anymore. Oh no, you can. 4 over 10 is 2/5. So now you got what? Oh no, you can still cancel, fool. 2 goes into 10 5 times. So you got 81 over 125, and that's easy to do. 44 over 125. Off the bat, that's the end. Okay, next page. Oh, you had 3 pages. Okay, so this was the same problem you had on your homework, except I did the other one, right? The complement of it. So it's like the same thing. So you have a square, A, B, C, D, and X is a randomly placed in the square. What's the probability that angle AXB is acute? So if you make a semicircle here, well, that doesn't really look like a semicircle. Yeah, that's a little better. So if X lies on the rim of the circle, then it's gonna make a right angle, right? So where does the point have to be so that the angle is less than 90 degrees? Inside the semicircle or outside?
Outside.
Yeah, it would have to be outside. So the answer would be the area of the shaded region divided by the area of the whole region, right? So how do you find the area of the shaded region? Square minus semicircle. So what do you want to call the radius of the circle? You can call it anything you want. 1, 2, R?
R.
Okay, R. So that would make this 2R. So how do I find the area of the shaded region? Square. What's the area of the square?
4R squared.
4R squared minus the semicircle. half pi r squared, and then divide that by the entire square. 4r squared, and what a surprise, the r squareds cancel out. So what do you have left? 4 minus pi over 2 over 4. Multiply top and bottom by 2, and you get 8 minus pi over 8. Box that, that's the answer. Alright? Number 6. Okay, this is going to be important for today's lesson here. In a jar, we got 5 red, 4 blue, and 3 green marbles. 3 marbles are randomly drawn. What is the probability that A, 2 are red and 1 is blue? Now remember, you can think of it 2 ways. You can draw marbles one at a time, or you can pull them all at once. So let's do it one at a time. Now the thing about doing it one at a time, there's an order, so you gotta multiply by the different orders. So do a specific case. Red on the first, red on the second, blue on the third. What's the probability of pulling out a red ball? 5 12s. Now another red. 4 11s, and then now a blue. 4 10s. But is that the only order that you can get 2 reds and a blue? No, so you need to multiply by the number of orders, or how many 3-letter words can you make? 3. 3 factorial over 2 factorial. And you can count it any way you want, but you need that number 3. So whenever you're pulling out one at a time, you have to multiply by the number of different orders. Or you can think of it as pulling out the balls all 3 at once. So if you do that, there is no order, so then you don't multiply by anything. So 12 marbles, how many ways can you select 3 of them? 12, choose 3. And you want 2 reds, so 5, choose 2. And you want 1 blue, 4, choose 1. And that's it. So either you write this down as your formula or that. You can do it either way, but again, you do it one at a time. You have to multiply by the different orders, because some of you are not multiplying by the orders. That's key. That's super important. And then of course you can cancel. 4 times 3 is 12. 5 goes into 10 2 times, 2 goes into 4 2 times, so what's left? 2 11s. That one should also come out to 2 11s as well. Part B, what's the probability that at least 1 is green? So again, we have the phrase at least 1. What do? Do the complement. So what's the complement of at least 1 is green? None are green. So compute the probability that none are green and subtract it from 1. That would be the easiest way. So, again, you can do it, how can you get no greens? You can do it one at a time. So, not green, not green, not green. So what's the probability of pulling out a ball that's not green? How many balls are not green in there? 9, so 9 out of 12. And then not green again. 8 out of 11, and then not green again. 7 out of 10. Is that the only order you can get 3 not greens?
Yeah.
Yeah. So that you don't need to multiply by anything, and then subtract it from 1. Or you can do the combination way. So 12 choose 3 is the denominator. How many balls in here are not green? 9. How many ways can I select 3? 9 choose 3, and then subtract that from 1. Either way, it doesn't matter. Anyway, what did this one come out to? 34 over 55. You guys should be able to do the computation. Yeah? C, one of each color is obtained if the marbles are replaced. So if you're going to look at the marble and put it back in the jar, you cannot pull out all at once. So in this problem, you have to do it one at a time. So let's do a specific case, one of each color. Let's say red on the first, blue on the second, green on the third. What's the probability of pulling out a red on the first? 5 out of 12. Put the marble back in. What's the probability of pulling out a blue? 4 out of 12. Put the marble back in. What's the probability of pulling out a green? 3 3 out of 12, but is that the only order you can get one of each color? No. How many 3-letter words can you make? 3 factorial or 6. That's your formula. And then of course, you gotta subtract. Wait, no, we're not doing that problem. That's it. That's your answer. All you gotta do is cancel. Anyway, I'll just give you the correct answer here. Save some time. You guys should be able to do computation. Third page. There was one card problem, and here it is. 3 cards are randomly drawn from a deck of cards, so 52 choose 3. The cards are normally like committee problems and combinations, right? What's the probability of obtaining exactly 1 pair? And I gave you an example, 2 kings and a card that's not a king. So do a specific case, which is that, 2 kings. How many kings are in the deck? 4. How many ways can you select 2 of them? 4, choose 2. How many cards in the deck are not kings? 48. How many ways can I select one of them? 48, choose 1. So this is how many ways you can get 2 kings. But what about like 2 queens or 2 jacks or 2 sevens? So I need to multiply that by 13. That's your formula. Now, some people did it one at a time, and you can do that. That works as well. So you could go king, king, not king, yeah? What's the probability of getting a king on the first draw? 4 out of 52. And then another king. 3 out of 51. And then now not a king. 48 out of 50. But is that the only order that you can get 2 kings? No. So again, how many 3-letter words can you make? 3. But that's just kings. What about jacks, 7s, and 5s? You gotta multiply by 13. So either way, you could have done it either way. Anyway, the answer should come out to 72 over 425. Because if I remember something from when I was correcting this, some of us have computation issues. We gotta fix that before we go to calculus. All right, there are 5 red, and I better write this down. 5 red and 2 black marbles in a bag. Bert and Ernie take turns drawing a marble. The first to draw the black marble is the winner. If Ernie goes second, what's the probability that he would win? So what's one way Ernie could win? Bert would get the red ball, and then Ernie gets the black ball, right? What's another way? Ernie, red, Bert, red. No. Who goes first? Bert. Bert, Ernie, Bert, Ernie. Then you get, Ernie pulls out the black ball on the 4th draw, right? And then, is this gonna fit in the camera? I'll do it down here. Bert, who goes first again? Doggone it. Yeah, Bert. Bert, Ernie, Bert, Ernie, Bert, and then Ernie pulls out the black ball on the 6th draw. Can there be any more cases? No, because you only got 5 red marbles, so these are the 3 cases. So what's the probability that Bert pulls out a red, 5 sevens, and then now the black ball comes up, 2 6. Now what about this case? Red, 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 and then now the black. And then this case here is red, 5 sevens, red again, red, 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 and then now the black, 2 out of 2, guaranteed will be black. And then you just gotta add up these numbers. 3 sevens is the answer. And then number 9 is the birthday problem. Okay, I can guarantee you this problem's gonna be on the test. You don't even, in fact, probably all of these are on the test. You're just gonna get different numbers. Number 9. So, I told you guys how to do this. Some of you just forgot. Look, here are the 4 people. Okay, like this. And we're going by months. Okay, so if you randomly select 4 people, what's the probability that at least 2 of them are born in the same month? So what's the probability that the first person is born in a particular month? 12 out of 12. And then what's the probability that the second person's birthday is different from the first? But see, you don't even have to know that, you just memorize the technique. That's it. So if you multiply these four numbers, that's the probability that all four of them have different birthdays. So if you subtract it from 1, you get the complement of that, which is, that's the probability that at least 2 of them will have the same birthday. Anyway, that's your formula, and then you just gotta simplify this. Again, in this one, there were lots of issues simplifying, I'm not sure why. You cancel people. You guys gotta learn to cancel. Some people not canceling. Like that, 3, 4, this is 5, 6. Why am I teaching you how to do this? Come on, you guys should know how to do that. Number, how come the last problem is number 7? That's weird. I think I copied and pasted off another quiz and then I forgot to change the number. Anyway, this is the cabin problem. I think we'll be seeing this on the test as well. Cabin A holds 6 people and cabin B holds 5 people. If 11 people are randomly assigned to these cabins, what's the probability that Mo, Larry, and Curly will room together? So there are 2 cases, Mo, Larry, Curly in cabin A or in cabin B. Now, if Mo, Larry, and Curly are in cabin A, how many more people do you need to select? Look, only 6 people can go in there. 3. And how many remaining people are there? 11 minus 3. 8. So out of the 8 remaining people, how many ways can I select 3 of them to go into cabin A with Mo, Larry, and Curly? 8 choose 3, and then what is the denominator? There's 11 people. How many ways can you select 6 of them to go into A? 11 choose 6. But it doesn't matter, because if you did B first, it would be 11 choose 5, but 11 choose 6 and 11 choose 5 are the same number. So that's why it doesn't matter. And then the other case is, what if they're in cabin B? So there's 5 people there. If Mo, Larry, and Curly there, you need to select 2 more people, so it's 8 choose 2. And the denominator is still 11 choose 6 or 11 choose 5, whichever one you want to do. Anyway, that's it. That's your formula. And then add up these numbers, which was an issue, 2 11s. All right. That was your review. So, huh? Oh, yeah. So today is probability 3. Let's see what it is. Oh, binomial probability. Does that have something to do with the binomial theorem? Why don't you guys like the binomial theorem? Why did I expect an answer? That's small pieces of chalk. That's what it is, I guess. Now, these problems, you guys can all do these problems already. You know how to do them, except there's a form, most books will make a separate section just based on this. So first of all, what is a Bernoulli trial? Here, let's write this down. What is a Bernoulli? You guys ever heard of the mathematician Bernoulli? What about physics? Okay, whatever. A Bernoulli trial, well, I guess if you're going to pronounce it properly, this is a French word, yeah? Who takes French? Bernoulli. You don't say L, you don't pronounce the L. Yeah, it's a Bernoulli. But whatever. We're going to Americanize it anyway, right? So, what if there's something that only has 2 possible outcomes? For example, tossing a coin, right? There's only 2 possible outcomes. And what if you do that repeatedly? Then we can use binomial probability to figure it out. So a Bernoulli trial is where you have something that only has 2 possibilities and you do it repeatedly. Now, like I said, you guys already know how to do this, but then we're going to develop a formula that makes it a lot easier. Just a little easier, actually. Okay, so let's say you toss a fair coin. Toss a coin how many times? 7 times. Toss a coin. You know what? Let's start off easy. Let's just go 5 times then, yeah? What's the probability of getting 3 tails? You guys already know how to do this. I can put you in a room by yourself. You should be able to do this. Okay, let's do a specific case. How can you get 3 tails if you toss a coin 5 times? You can get tail, 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 head, head, right? Isn't that one possibility? Okay, what's the probability of tossing a tail? 1/2. Tail. Tail. What about head? 1/2. 1/2. But then, is that the only order you can get 3 tails? No, so how many different orders are there? How many 5-letter words can you make? 5 factorial over 3 factorial, 2 factorial, which is the same thing as 5 choose 3 or 5 choose 2, right? So I don't care what you do, you can put 5 factorial over 3 factorial, that's how many 5-letter words you can make, but that's the same thing as 5 choose 3 or 5 choose 2. Or you could like count it by hand. The 2 heads could have been here, 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 here. Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that the same thing as 10? Yeah, so you could just count it and you get 10, but you gotta come up with that. Okay, but since there's only 2 possible outcomes, we can make a formula from this. So if you read books, but you guys don't, yeah, like your Algebra 2 book from last year, or any pre-calculus book off the shelf, this is a formula to do. So first of all, n is the number of trials that you're doing. How many trials are you doing here? You're tossing a coin 5 times, so what is n? 5. That's the number of trials. Okay? R is the number of successes, because if there's only 2 possible outcomes, either success or failure, right? So what should we define as a success in this problem? Getting a tail, tossing a tail, right? So how many successes do we want? 3, right? What's the probability of a success? What's the probability of tossing a tail? 1/2, and therefore, since there's only 2 possible outcomes, what would be the probability of a failure? Wouldn't it be 1 minus p then? No, it's not always going to be 1/2, because what if you have an unfair coin? What if it comes up tails 2/3 of the time, because the density is different on both sides? Then the probability could be 2/3. Therefore, the probability of a failure would be 1/3, then, right? Just subtract it from 1, because there's only 2 possibilities. You get that? So we call this is the probability of a success. If you subtract it from 1, therefore it's the probability of a failure. So you can see how this works here. So this is the formula that they will teach you if you actually read a book in the probability chapter. So the probability of getting 3 successes would be 5 choose 3. That comes from these 2 numbers here. The probability of a success to the 3rd, because that's what you want 3 successes, and the probability of a failure to the 2nd. Well, actually, you know what? Why don't I write the general? The general formula looks like this. N choose R. Probability of a success to the R. Probability of a failure, N minus R. This is the formula that you'll see in the book. But can you see that this is exactly the same thing as this right here? Because isn't this 5 choose 3? That's this thing here. And then you got 1/2 to the 3rd, and then 1/2 to the 2nd. It's exactly the same thing. You don't need this formula. So if you don't want to pay attention to this formula, you don't have to. But it just makes some computations a lot easier. So let's do a different problem. Instead of tossing a coin, let's roll a die. Now you're gonna say, yeah, but Mr. Park, there's 6 possibilities. No, it just depends on the problem. So let's say we roll a die. How many times? Let's do it 6 times then. We're gonna roll a die 6 times. What's the probability of getting 4 ones? So if we want to do the binomial probability way, what is that? How many trials are there? 6. R is how many successes? successes. So if we define a success to be rolling a 1, then how many successes do I want? 4. What's the probability of a success? What's the probability of rolling a 1? 1/6. Therefore, the probability of a failure not rolling a 1 is 5/6. Can you see? That's why it's not always going to be 1/2. Okay, so therefore, what's the probability of getting 4 1s? Use this formula. It's really, once you write this down in your paper, you might as well do it this way. 6 choose 4, success to the 4, failure to the 2, because these two are going to add up to that, right? N minus R. And then, of course, I'm pretty sure you write that down, that's a formula. So you're going to get 3 out of 4 points. You just got to, I'm pretty sure you can, I don't know if I'm pretty sure. I think you guys can compute this. Cancel. Don't multiply out like a crazy person. Okay, so now, what would be the probability of getting at least 4 1s? So now you gotta ask yourself, what does at least 4 1s mean? 4, 5, or 6, right? Or should I do the complement? What's the complement of at least 4 1s? 3, 2, 1, or 0. Which one do you think is easier? Compute it directly or do the complement and subtract from 1? Yeah, this one is directly, I think would be faster. So at least 4 1s means 4, 5, or 6 1s. So you have n trials, 6. How many successes do we want? 4, 5, or 6. The probability of a success is 1/6. The probability of a failure would be 5/6. Throw it into the formula. So 4 1s, 6. Well, we actually did it right here. Why reinvent the wheel, right? Now, what about 5 successes? 6 choose 5. 1/6 to the 5. Failure to the 1, because these two powers are going to add up to this. And then what about 6 successes? 6 choose 6. 1/6 to the 6. 5/6 to the 0. There you go. That's your formula. And then just gotta compute that. Now, does this have anything to do with the binomial theorem? Yes, it has everything to do with the binomial theorem. Let me erase this. So look at what we just wrote here. Doesn't that kind of look like you're using the binomial theorem? What are you actually expanding when you do this? Like binomial theorem, we go a plus b to the n, right? Oh, by the way, over this vacation, you guys had fun yet? You know what I did? I made written solutions for every chapter. Because like I told you, last year when we went online, I did it all on Zoom, and then there was no written solutions. It's just you watch that. But then the students are telling me that it's easier to look at written solutions, so that's what I did over the whole vacation. Make written solutions for PCH.
Thank you.
You're welcome. Anyway, binomial theorem. So tell me, what do I have to expand to get these numbers here? One 6 plus 5/6 to the 6. That's what you're expanding. Okay, let's review the binomial theorem since some of you forgot. So what would the first term be? 6 choose 0. The power of a 6. And then the power of b. Okay, the next one gonna be 6 choose 1. The power of a goes down by 1. The power of b goes up by 1. Next term, 6 choose 2. The power of a goes down by 1. The power of b goes up by 1. And then 6 choose 3. The power of a goes down by 1. The power of b goes up by 1. And then those are the rest right there. That's the binomial theorem. So what does this represent? What does this first term represent? This is the probability of getting no 1s. This would be the probability of getting 1 1, 2 1s, 3 1s, 4 1s, 5 1s, and 6 1s. looking at your homework, so binomial probability, you only have, it's the first 5 problems. The last 2 problems are just review. Look at it, it's number 6. That looks like the quiz problem, right? The jar with the marbles. So the first 5 problems are binomial probability, and the last 2 just review. So this homework should be, this is one of the easiest homeworks of this chapter. And then it's gonna get tougher, starting tomorrow. So any questions on this? Use the formula. To me, if you use the, you gotta recognize when you can use the formula though. You just have something that has only 2 possible outcomes, and then you do it repeatedly. That's when you use binomial probability. Okay, then we'll finish early today then.